When we imagine the ultimate threat to modern civilization, we usually picture a team of nation-state hackers. We worry about malicious code infiltrating our electrical grid, bypassing firewalls, and causing the lights to flicker and die across entire cities. But the primary threat taking down power grids every single day is actually this guy. While governments prioritize cybersecurity, ordinary animals cause tens of thousands of power outages globally every year. The electrical grid is an exposed physical asset sitting in the wild. This makes it vulnerable to basic biology in a way that an abstract digital network is not. To track this, security researchers built a dataset called Cyber Squirrel 1. It logs confirmed operations executed by wildlife against critical infrastructure. This chart maps the volume of confirmed incidents. On the bottom, there are exactly 3 confirmed human-caused cyber operations impacting critical infrastructure. Above it, squirrels alone account for over 1,200 documented outages. This assessment is shared by the highest levels of national security. John C. Inglis, former deputy director of the NSA, explicitly stated that the #1 threat to the U.S. electrical grid is squirrels. While national security focus remains on digital defense, the actual war for grid stability is being fought on a biological frontline. To see how a tiny animal brings down millions of dollars of hardware, we have to look at substations. These nodes are attractive to animals because they provide a stable source of warmth and shelter. Distribution networks rely on precise air gaps, typically 40 centimeters, to prevent high-voltage arcing. When an animal enters this space, it reduces the distance below the breakdown threshold. High-voltage plasma jumps the gap, passing through the animal, creating a short circuit. Rodents are driven into these spaces by a biological need. A squirrel's incisors grow continuously throughout its life, forcing the animal to gnaw on tough materials like wire insulation to file them down. This behavior strips away the protective coating and exposes live conductors. Snakes act as a similar vector. Their elongated bodies allow them to navigate gaps in perimeter fences and bridge wide electrical terminals that would deter other species. For these bridging species, ordinary biological needs accidentally transform into fatal biomechanical triggers that exploit the spatial design of the grid. When animals swarm, the threat scales from individual accidents to massive infrastructure failure. Texas fire ants, for example, are attracted to the heat and low-level electromagnetic fields generated by electrical switching mechanisms. When an electrocuted ant enters a switch, it triggers a chemical feedback loop. Right before death, it releases an alarm pheromone, attracting thousands of workers. As bodies pile up, they create a solid conductive bridge, causing a permanent short circuit. Massive thermal and nuclear power plants face a different biological challenge at their cooling water intakes. Coastal plants in France and Sweden are frequently overwhelmed by massive jellyfish blooms. These gelatinous organisms are sucked into the seawater intake gates, jamming the primary filter drums. This triggers an automatic reactor shutdown, instantly removing gigawatts of production from the grid. Whether through chemical pheromone loops or sheer physical biomass, swarm behavior proves the grid is highly vulnerable to the collective biology of tiny organisms. You cannot patch a squirrel vulnerability with a software update. While digital defense is necessary, grid operators must rely on physical hardening to address biological threats. Utility strategies are shifting to treat animal disruptions as preventable design flaws, rather than unpredictable acts of nature. Engineers are deploying physical firewalls, UV-stable polymer covers, cold-applied insulation, and specialized guards that shield bare metal connections. This chart of bird silhouettes illustrates how safety distances are being recalculated. Engineers now define spatial clearances based on the biomechanics of local fauna, specifically the exact wingspans of native bird species. True grid security requires physical engineering that is tailored directly to the biology of local wildlife. As climate change extends breeding seasons and human development encroaches on habitats, the biological threat to the grid is only expanding. The ultimate resilient grid must balance its investments in digital defense with an equal respect for the relentless force of nature. The next time the lights flicker and die, it's probably not an international cyber incident. It's a biological agent completing a circuit it shouldn't have, and a protection relay doing exactly what it was designed to do.